My name is Bino, and in this video we'll be focusing on question 2 from the November 12, 2020 N6 mathematics question paper. Question 2.1, we are given the integral of e to the power negative 3x cos 3x dx, and to evaluate this integral we have to use integration by parts. So the formula for integration by parts, we have the integral of f of x g prime of x dx is equals to f of x g of x minus the integral of g of x f prime of x dx. So as you can see, we have an exponential function e to the power negative 3x and a trigonometric function cos 3x, and we have to determine which between e to the power negative 3x and cos 3x will be equals to f of x and which will be equals to g prime of x. And we do that by the use of the Eilert rule, where the first one which we come across going to the right will be equals to f of x. As you can see, the t comes before the e, so f of x will be equals to the trigonometric function cos 3x, and g prime of x will be equals to e to the power negative 3x. We differentiate the f of x and integrate the g prime of x so that we can get g of x. So the integral of e to the power negative 3x will be equals to e to the power negative 3x divided by negative 3, and the integral of cos 3x will be equals to negative sine 3x multiplied by the derivative of the 3x, which is equals to 3. So f prime of x will be equals to negative 3 sine 3x. From here, we have to substitute into that formula. So we have our f of x, which is cos 3x, and our g prime of x, which is equals to e to the power negative 3x dx, and this will be equals to f of x multiplied by g of x. Our f of x is equals to cos 3x, and g of x is equals to e to the power negative 3x divided by negative 3 minus the integral of g of x. G of x is equals to e to the power negative 3x divided by negative 3 multiplied by f prime of x, which is equals to negative 3 sine 3x dx, and this will be equals to negative, so let's take that negative 1 over 3 cos 3x e to the power negative 3x, and that negative 3 and that negative 3 will cancel out each other, and we'll be left with the integral of e to the power negative 3x multiplied by sine 3x dx. And again, to evaluate this integral, we have to use integration by parts. So we have to evaluate this integral. So the integral of e to the power negative 3x multiplied by sine 3x dx, we have to figure out which one will be equals to f of x and which one will be equals to g prime of x. So as we saw, the trigonometric, so we have a trigonometric function here and an exponential function again, and the trigonometric function comes before the exponential function, so the trigonometric function will be equals to sine 3x, and e to the power negative 3x will be equals to the g prime of x. We differentiate the f of x with respect to x, so the derivative of sine is cos 3x, and the derivative of the 3x is equals to 3, which we can write there. The integral of g prime of x, so that we can get g of x e to the power negative 3x. The integral of e to the power negative 3x will be equals to e to the power negative 3x divided by negative 3. From here, we substitute. So we are supposed to have another. So integral of f of x g prime of x dx is equals to f of x g of x minus integral of g of x f prime of x dx. So we have e to the power negative 3x multiplied by sin 3x dx, and f of x multiplied by g of x, or f of x in this case is sin 3x, and our g of x is equals to e to the power negative 3x over negative 3 minus the integral of g of x multiplied by f of x, f prime of x. So g of x is equals to e to the power negative 3x over negative 3, and f prime of x is equals to 3 cos of 3x dx. So that 3 will cancel out with that 3, and that negative will cancel out each other. So the integral of e to the power negative 3x sin 3x dx will be equals to negative 1 over 3 sin 3x e to the power negative 3x. That negative multiplied by that negative will be positive. The integral of e to the power negative 3x multiplied by cos of 3x dx. So originally we had that integral, and we went outside of that integral to look for the integral of that, and the integral of that is equals to this. So we can go back to our original integral, the integral of cos 3x e to the power negative 3x dx. We said this is equals to negative 1 over 3 the 3 minus the integral of e to the power negative 3x and x sin 3x, which we determined the negative, the integral of that we determined as negative 1 over 3 sin 3x e to the power negative 3x plus the integral of e to the power negative 3x multiplied by cos 3x dx. So this negative will multiply throughout inside the parentheses. So this side we have the integral of cos 3x e to the power negative 3x dx, and this is equal to negative cos 3x e to the power negative 3x divided by 3. This negative multiplied by that positive 1, this negative multiplied by that negative 1 over 3 will be equal to positive 1 over 3 sin 3x e to the power negative 3x, and the negative multiplied by that positive will be negative e to the power negative 3x cos 3x dx. As we can see, we have we have the integral of cos 3x e to the power negative 3x dx this side, and we also have the integral of e to the power negative 3x cos 3x, but they are just arranged differently. So we have the cos 3x, we have the cos 3x, we have e to the power negative 3x, we have e to the power negative 3x. So these two are the same. So we can take this and we can take this to the right. So we already have the integral of cos of 3x e to the power negative 3x dx. We take that one, is going to change sign from negative to positive. Integral of e to the power negative 3x cos 3x dx, and we'll be left with negative cos 3x e to the power negative 3x divided by the 3 plus 1 over 3 sin 3x e to the power negative 3x. So these two are the same, it's just that they are arranged differently. So we can add these two, and we'll have 2 times of these. So we have 2 times the integral of cos 3x e to the power negative 3x dx, and this is equal to negative cos of 3x e to the power negative 3x divided by 3 plus 1 over 3 sin 3x e to the power negative 3x. So we can divide, because we are looking for the integral of that, we can divide both sides by 2 so that we can remove that 2. So that 2 will cancel out with that 2. So the integral of cos of 3x e to the power negative 3x dx will be equals to this 2 multiplied by that will be negative 1 over 6 cos 3x e to the power negative 3x plus 2 multiplied by that 1 over 3 will be 1 over 6 sin 3x e to the power negative 3x plus c. Question 2.2, we have to evaluate the integral of the square root of minus c minus x squared minus 6x dx. In most question papers, they forgot to include the square root. So the first step is for us to take what's inside the square root and we organize it. So this is what's inside the square root and we organize it in standard form so that we can use, so that you can complete the square in order for us to evaluate this integral. And in order for us to use complete the square, we have to make sure that there is no number or a negative sign in front of the x squared. So that's why we are taking negative x as our common factor, so that only positive 1 can be left as the coefficient of the x squared. So this will be equals to positive 6x plus c after we take negative as our common factor. And in order for us to complete the square, we have to take the coefficient of x, this 6, and we have it, we square the whole thing and we minus this whole thing by itself. Notice that we didn't change this expression, so this is just equal to this because this minus that will be equals to 0. And the next step is for us to now factorize this part. And the factorization, okay, before we do that, so 6 divided by 3 is 6 divided by 2 is equals to 3. And from here we factorize this part, and the factorization always goes like this. So we take this one of the x here, we put it here, the sign that is here, we put it here, and we take one of the 3's and we square the whole thing. So this, if you were to expand this part, you will find that this is equals to that. So we'll be left with the negative 3 squared, which is 9, plus c. So from there, you cannot square this 3, you just leave it like that so that you can be able to factorize it this way. And from here, we can distribute this negative inside the parenthesis. So negative multiplied by positive will be negative x plus 3 squared. Negative multiplied by negative 9 will be equals to positive 9. Negative multiplied by positive c will be equals to negative c. From here, we have to use our formula sheet. So on the formula sheet, there are 2 formulas that we should apply, either this one or that one. But this one, it has the x as positive, and here the x is attached to a negative. So we have to use this other one, which has negative attached to the x. So we have the square root of 9 minus c minus x plus 3 squared dx. And from here, we have to rearrange our integral so that it can suit that one. So let's see, we have to have the a squared, so we can write this 9 minus c as the square root of 9 minus c squared, so that we can have that square root. But we cannot just have that square root, we have to include this we cannot just have that square. We have to introduce this square root so that this can be equals to this 9 minus c. So this will be the integral of the square root of 9 minus c squared minus, and we have b there, so we have 1 there, so we can just say 1 squared, which is equals to 1. We are trying to rearrange it in that form. So in the place of the x, we have the x plus 3 squared. So they squared the x, so we only have to square the x plus 3 dx. So the integral of this whole thing will be equals to, so a in this case will be equals to the square root of 9 minus c, and when you square this a, you'll get back the 9 minus c, and b in this case will be equals to 1. So the integral of a squared divided by 2b, so the a squared is just equals to the 9 minus c divided by the 2, the b is equals to 1, arcsine of b, which is equals to 1, x, we don't have x, we have x plus 3, which is squared. So what's squared here is the x plus 3, but what's squared with them is the x. So we have the x plus 3 divided by the a, which is the square root of 9 minus c, plus x. So they have x, we have x plus 3 over 2, and from here we just copy what's, so we just copy this thing the way that it is. So we'll have 9 minus c, so there is no need for us to include the square root and the square, minus x plus 3 squared plus c. And this will be our answer for question 2.2. Question 2.3, we have to evaluate the integral of cos cube x minus cos to the power 5x dx. And since we have our exponents as odds, so this is only valid for sine and cos. So if for sine and cos you have exponents which are odd, the first thing that you must do is for you to break them down and convert them. So step 1, we break them down. So we break this as cos squared x multiplied by cos x, which we know is equal to cos cube x, minus, we break down that cos to the power 5x as cos to the power 4x multiplied by cos x dx. And we know from our trigonometric identities that sin squared x plus cos squared x is equal to 1, also available on the formula sheet. So when we make cos squared x the subject of the formula, we'll get that cos squared x is equal to 1 minus sin squared x. But before we can do that, let's break down that cos to the power 4x further. We have cos squared x multiplied by cos x, that we can write as cos squared x raised to the power 2, which is equals to that multiplied by cos x dx. So in the place of the cos squared x and the cos squared x, we will substitute 1 minus sin squared x because it is equals to cos squared x. The integral of 1 minus sin squared x in the place of the cos squared x, and we are left with the cos x. So same thing, 1 minus sin squared x, but this is raised to the power 2 cos x dx. So from here, let's distribute this cos x inside the parenthesis. So 1 multiplied by cos x is equals to cos x minus sin squared x multiplied by cos x will be equals to sin squared x cos x. So we can expand this, but it will be much work. So let's try to use the technique where we don't have to expand it. So 1 squared is equals to, so we have 1 squared. So we take this 2 from the exponent, we multiply it with that 1, we multiply it with the negative sine squared x, and from here we square this negative sine squared x, and this will be equals to positive sine to the power 4x, because even the negative will be squared, and we have the cos x and our dx somewhere there. So this will be equals to 1. So this 2 multiplied by 1 will be 2. And that 2 multiplied by negative sine squared x will be equals to negative 2 sine squared x plus sine to the power 4 x, and our cos x dx. So we have the integral of cos x minus sine squared x cos x. So let's distribute this negative inside the parenthesis. So negative multiplied by positive 1 will be equals to negative 1. But before you do that, you have to also, so let's keep it that way. So let's distribute this cos x first inside this parenthesis. So this cos x multiplied by 1. So negative 2 multiplied by negative 2 sine squared x multiplied by that cos x will be equals to negative 2 sine squared x cos x. So sine to the power 4x multiplied by cos x will be equals to sine to the power 4 cos x, and this whole thing dx. So we can now distribute the negative sign. So negative multiplied by positive cos x will be equals to negative cos x. Negative multiplied by positive 2 sine squared cos x will be equals to positive 2 sine squared x cos x, and this negative multiplied by that positive will be negative sine to the power 4 x cos x dx. So we can group the like terms. So this cos x, we group it with that negative cos x. So this negative sine squared x cos x, we group it with this positive 2 sine squared x cos x. So we are left with that negative sine to the power 4 cos x dx. So this cos x minus cos x will be 0. Negative sine squared cos x plus 2 sine squared cos x. So we'll be left with only 1 sine squared x positive, because that 2 is positive, cos x minus sine to the power 4 x cos x dx. From here we can let, we have sine and sine, but let's distribute this integral sign and the dx inside the parentheses. So the integral of sine squared x cos x dx minus that minus the integral of sine to the power 4x cos x dx. We have sine and cos and cos, so we can let u equal sine x. So we differentiate u with respect to x. The derivative of the sine x is equal to cos x. When we differentiate that x, you get 1, so there is no need for us to multiply by it. We multiply both sides by dx, so that dx can cancel out with that dx. So du will be equals to cos x dx, and we have cos x dx there. So in the place of these two cos x dx, we will just substitute du, because du is equals to cos x dx, and in the place of the sign we substitute u. But the sign there is square, so you also square the u. In the place of this we substitute the du minus the integral, so sine, we replace it with u, it's raised to the power 2, even our u, we do that, du in the place of cos x dx. So standard integral, so the integral of u to the power 2 with respect to u will be u to the power 3 over 3 minus the integral of u to the power 4 u to the power 5 over 5 plus c. Let's substitute back the sine x in the place of u. So this will be sine cube x over 3 minus sine to the power 5 x over 5 plus c. And this will be our answer for question 2.3. Question 2.4, we have to evaluate the integral of tan to the power 4 of 4x dx. We can break this and we write it as tan squared 4x multiplied by tan squared 4x dx. And from here, we know from our trigonometric identities that 1 plus tan squared x, 1 plus tan squared x is equals to sec squared x. Number 2, this will be equals to sec squared x. So we make tan squared x the subject of the formula. And we have sec squared x. We take that one to the right. It's going to change sign from positive to negative. So in the place of this tan squared x, we will substitute sec squared x. But we do that only for the first one, or we can choose the second one. Okay, but this is 4x, so this is not like, so we have 1 plus tan squared 4x is equal to sec squared 4x. So tan squared 4x is equal to sec squared 4x minus 1. We differentiate, so this will be, so in the place of the tan squared 4x, we'll substitute sec squared 4x minus 1. So we leave the first one, we substitute it on the second one. So this will be sec squared 4x minus 1 dx. Let's substitute, let's distribute the tan squared 4x inside the parentheses. So this will be equals to, so tan multiplied by that will be equals to tan squared 4x multiplied by sec squared 4x, and this tan squared 4x multiplied by that negative 1 will be negative tan squared 4x. So we distribute the integral and the dx inside the parentheses. So from here, so only on that part, so that part, the integral for tan squared x should be available on the formula sheet. I don't have a formula for n6, but the integral of tan squared 4x will be equals to, okay, so we'll figure out the integral of tan squared 4x, but for now we have to let u equal tan 4x, and we differentiate u with respect to x. So the derivative of tan is equals to sec squared 4x. And according to the chain rule, we also have to differentiate the function of the function. So the derivative of the 4x is equal to 4. We multiply both sides of the equation by dx. That dx will cancel with that. So du will be equal to sec squared 4x 4 dx. So we have sec squared 4x dx without the 4. So let's divide both sides by 4. That 4 will cancel out with that 4. So du over 4 will be equals to sec squared 4x dx. So in the place of sec squared 4x dx, we will substitute du over 4. And in the place of tan, we substitute u. In the place of tan 4x, we substitute u, but that tan is raised to the power 2, so also square that. In the place of that sec squared 4x, we substitute du over 4 because it is equals to sec squared 4x dx. So from here we integrate, so the integral of u squared with respect to u, so let's write the 1 over 4. So the integral of that u squared will be equals to u to the power 3 over 3, that 1 over 4 is there. And the integral of tan squared 4x, if I'm not mistaken, is going to be, so tan of ax will, so the integral of tan squared ax will be equals to 1 over a tan of ax minus or plus, I'm not sure, minus, so let's stick with minus x, and a in this case we have tan squared 4x, so a will be equals to 4. So the integral of tan squared 4x will be equals to 1 over 4 tan 4x minus x, I'm not sure about this minus sign, plus c. So this will be equals to, so that negative stand alone, so we have 1 over 4 tan 4x minus x plus c. In the place of the u, let's substitute back. We said that u is equals to tan 4x, so let's substitute back. Let's substitute back the tan 4x, and the denominator 4 multiplied by denominator 3 will be equals to 12, and we have tan cube 4x. This negative multiplied by that will be equals to negative 1 over 4 tan 4x. That negative multiplied by that negative will be equals to positive x plus c, and this will be our answer for question 2.4. Question 2.5, we have to evaluate the integral of ln of 1 over x dx. So we can write this as integral of ln of, so that 1 over x, we can write it as x to the power negative 1 dx, and we know that ln of a to the power 2 will be equals to 2 ln a. So this we'll write as that negative, just like the 2 was dethroned from the exponent to the base. So let's also dethrone that negative 1. Dx, so negative integral of ln x dx. So the integral of negative ln x from the formula sheet is going to be x ln x minus x plus c. So we distribute the negative sign, so negative x ln x plus x plus c, and this will be our answer for question 2.5.